Hi, I'm Mark Paulson, and welcome to another edition of Ground School. So we've been talking about some of the different weather um, types that we can be affected by in flight and all that. And now we're going to talk about some of the ways that they measure those different types of weather before we get to some of the products that we use to actually plan our flights and that kind of thing. So some of the first one I want to talk about is the surface observation. And then we're going to talk a little bit about radar and then some different types of satellite images, and also weather balloons, which are still largely in use. And then also some of the ways that we can access that weather. And then we're going to get more into the products that are created from these observations later on. So first, we're talking about surface observations. And you might know this as ASOS or AWOS. And so the surface observations is a joint project between the Department of Defense, the National Weather Service, and the FAA as well. So, and basically what that boils down to is a ground station, and that ground station has different types of sensors on it, and it measures just general weather at a specific location on the ground. And they're usually located on an airport, near the touchdown zone, at least the approach end of a precision approach or an instrument approach. So you got a ground station, and usually near an airport. And some of the things that measures, we have a barometer, which measures barometric pressure, which we use for our altimeter settings. We have an anemometer, which measures the wind. We have something that's actually called a ceilometer, which measures the ceiling. And what that does is just sends pulses up into the sky, and when those laser pulses return, then it measures the time it took for them to get there, easily converted into height above the ground for our ceiling. All right, so we've got pressure, and we've got wind, ceiling, and I can also measure visibility. Not all of them can measure visibility, but visibility is just used by actually using a smaller chunk of the sky, about 3/4 of a foot actually. Excuse me. And then it uses the data in that little small area to calculate the estimated distance, and it's usually within 2 to 3 miles accurate. And so visibility. And so the surface observation is where the controlled airports would get its ATIS. They use this information and convert it into what they think would be more usable for the pilot, and they can make little adjustments based on their own personal observations as well. Alright, so the next thing I want to talk about is radar. The new edition of radar, it's installed pretty much all across the country now at all the major airports and a lot of different independent sites for news channels and that kind of thing. It's called NEXRAD, which stands for the Next Generation Radar. And what this has as an advantage over the old radar is that it can actually kind of see into the clouds with this thing they call dual polarization. And they're able to, like I said, see inside a cloud and differentiate different types of precipitation, like rain, snow, hail, that kind of thing. So it kind of gives like a 3D image almost of a cloud. And it's also able to differentiate between precipitation types. All right, and then they can use that. It's really advantageous in both forecasting thunderstorms and actually noticing embedded thunderstorms, which are really hazardous to IFR flight especially. So it can kind of, this is a really neat tool for those guys who are flying in the clouds. So they can identify T-storms, basically. All right, and as far as satellites go, there's three basic types of satellites. There's the visual, and infrared, and water vapor. And the visual is really useful for getting a broad picture of the sky cover. So if you're, especially on a long cross-country flight or something like that, and you want to know, like, okay, well, where do the clouds stop? Take a look at this visual image, and it'll kind of show you not only movement of the clouds over a certain period of time, about a half an hour. It'll also show you when the clouds, or where, in reference to the ground, the clouds are going to kind of stop or the skies will open up. So you have movement, as well as cover. The downside to the visual is that as soon as the sun goes down, it's no longer available. So sometimes you'll pull up a satellite image and half of the country will be black because it's nighttime over there, so not usable at night. Now the infrared is available all the time, and basically it shows basically the same thing as the visual, except that it is usable at night. So it's both usable at night and shows cloud cover. And the water vapor is pretty important because it'll tell you what the moisture content of the cloud is, which, you know, once it becomes saturated enough to create precipitation, it creates a good way to anticipate that, like rain down below the clouds. So it shows like the potential for precipitation. And it'll also show you cloud cover, but not as broad a scope as the visual or the infrared. Let's see, and so the next thing we'll talk about is weather balloons. These weather balloons, they provide kind of like a snapshot of the entire Earth's atmosphere at any given time. They're launched every day, 2 times a day, at 0 Zulu and 1200 Zulu. And then 1200 Zulu. And we actually have one in Oregon. It's located down in Salem. They launch those, like I said, twice a day. And they basically contain what's called a radiosonde. And it's everything that's used in the surface observation, except they send it into the air and it measures continuously as it tracks up through the atmosphere. That's why it kind of gives it a snapshot, because you've got all these balloons going up at the same time, and basically all that data is being transmitted back down to the ground, and get a pretty good idea of what's going on aloft. And I got a picture of them actually right here, so you can see that. And you can get these on the National Weather Service or NOAA's website. And that's how we get our winds aloft, pressures at altitude. It's a good way to see if there's a temperature inversion or at what point the freezing level is, or where the temperature and dew point meet to create that icing potential. So it's pretty interesting. So the next thing we're going to talk about is quickly how we can access some of these observations, mostly while in flight. They create a lot of weather products for these, which we're going to get to in a later lesson, but for now, there's something I want to mention. It's called EFAS, which stands for En Route Flight Advisory Service. Another common term is Flight Watch, and you can contact them on the radio at 122.0. And they're available, I think, mostly 6 in the morning until 10 at night local time. And another way we can utilize these observations is by tuning to a VOR. And sometimes they'll have a little H inside the VOR identification box, and that stands for HIWAS. I have to look for that. Yeah, Hazardous In-Flight Weather Advisory Service. Sorry. And that's only on some VORs, but it'll have that little H identifier, and they will give you any kind of hazardous information in the vicinity of that VOR. Let's see, and then more technologically advanced aircrafts, they also have what's called FISB. And it's Flight Information Service Broadcast. And that's attached to some of the more modern, technically advanced aircraft with their glass cockpits and everything like that. And it's kind of got a constant weather advisory that comes into the cockpit from some of these weather services. All right. So basically, what we have is we have surface observations, which is used more locally to get your local airport weather for your departure and arrivals. You've got radar, which helps see into the clouds to predict some of the weather that's going to be created by that cloud formation. Some satellites that allow you to see how broad of scope the clouds cover, like a certain area, or what kind of precipitation they contain. And then the weather balloons will give us a snapshot of the atmosphere, and then we can access all that information in a couple of different ways, the most common being Flight Watch, and that's where you give your pilot reports if you see weather that's on forecasts, or you just want to let them know what's going on where you are. And you can also get information if you're in a location that doesn't have a local ground station. All right, so thank you very much, and I'll see you guys.